Yesterday, we talked about how AI is as much a dream being sold to people as it is an actual product. That dream, of course, is that you can give a computer very loose, light instructions, walk away, go to the beach, and come back in 4 hours, 10 hours, 2 days, and you have a working product that you can sell. That is the future that AI promises. We talked previously about a tweet that kind of represented this, but when you dug in, it was really more clickbait and bullshit. Today, we're going to talk instead about a case where it actually worked. And to do so, we need to introduce one Simon Willison. Simon is an extremely popular blogger. He has a Substack with over 40,000 subscribers. He has one of the most popular web blogs, frequently cited and on the front page of Hacker News. So let's take a look at what he did. He ported an HTML5 parser, just HTML, from Python to JavaScript in about 4.5 hours. Was that 4.5 hours of effort? Was that 4.5 hours of prompting following along? No. Actually, during this time, he went and bought a Christmas tree with his family and watched the latest Knives Out movie. The LLM, in the meantime, was chugging through about 100 million tokens in that time before it ultimately arrived at the solution. So, what can we learn from this, and what are the key takeaways? Let's start by understanding exactly what he was doing. So, HTML5 parsing, what is that? Well, when your browser makes a request, here I have the DevTools open, across the network to get HTML, what it receives is actually text. But text by itself is not particularly useful. This is not easy on the right to read the response. What we would prefer is that everything be nicely formatted as it is on the left, with formatting, placement, layouts, different sizes of text, etc. Hyperlinking. These are all nice things. So in order to do that, what the browsers do is they take this textual format and they break it down into what's called the DOM. There's the document object model, which is a tree where you hierarchically break things down. You can see, as I move through, different elements of the tree being highlighted over here. So it's incredibly useful. So number one, the thing that he was working on was not trivial. So let's see the prompt that he used. We're going to create a JavaScript port of just HTML and HTML5 parsing library that passes the full HTML lib test suite. It is going to have a similar API to the Python library, but in JavaScript, and it will have no dependencies other than raw JavaScript. Hence, it will work great in the browser and Node.js and other environments. Start by reading just HTML and designing the user-facing API for the new library. Create a spec.markdown containing your plan. So that's not much of a prompt overall, right? Not a whole lot of user input. The machine goes off, the machine runs. Well, no, it's a massive amount of input. So for one, he's taking ML Stenstrom's just HTML5, so the library that is being ported. He's using its API as well as keeping the rough structure and everything else there. Additionally, there's the HTML5 lib tests, which are about 9,200 unit tests and integration tests that you can use to make sure that you're on track. This is providing signal to the agent as it goes through the process of translating it. So this is a tremendous amount of context overall. And in fact, that is what makes this so successful. We should touch briefly also on ML Stenstrom's work. So Simon had discovered his work a day ago, and it had been a several month-long effort where ML was trying to, from scratch, to create a Python implementation of an HTML5 parser. He found this to be fairly challenging, even though he took a very principled approach. Simon uses the term vibe engineering, oops, sorry about that highlighting, for the grown-up version of vibe coding, where expert coders use coding agents in a professional and responsible way to produce high-quality, reliable results. And here we get a breakdown of the process. This took ML several months, but he started off by hooking in the 9,200 test suites. As any developer can tell you, there is nothing that will help you more in life than having a good backing test suite. Very rarely do you have that, and more often what you have is an incomplete spec that doesn't specify all the different behaviors that should happen. And so then you have to go back either to stakeholders or you have to just decide yourself what all the behaviors should be. So this by itself is a huge, huge win. Additionally, ML provided the core API design himself. So rather than allowing the agent to do it, he said, here's roughly what the overall shape of the API should look like. Fill in the details. Even with this very principled approach and all this context, he was still struggling. And so he threw out the original code and started from scratch using a Rust library as a rough point to port from. That got him further. His full account is over here. I've read it, and he kind of breaks things down. This is a nice high-level synopsis, though. So that got him basically there, and then he took it a little further with some custom profiler and benchmarking tools to allow for more signal to go back to the agent to improve the performance, and he removed some unnecessary code. So this was the course of several months with some pretty substantial failures and a lot of work going in as a human implementer. It's important to note, the reason why I like this so much is because you start to see the limitations of the tooling combined with the amount of care that has to be used to get the best performance. So what Simon did, Simon built on top of all this. So he is pulling in this guy's work, which was 1,300 commits to get to that point. And he's pulling in the HTML5 lib tests as well, which, again, almost 9,000 tests. And then that resulted in his own port here. And I think that's fantastic for so many reasons. One, it shows that this was not some magical prompt. This was a lot of effort, a lot of work, and then it took us to a point where we have an essentially solved problem. Now we can move it between different coding languages. It's become essentially a translation task at this point, which is kind of what we're doing when we're vibe coding, is we're giving English descriptions of desired functionality, and then things are being translated over into code. So translation, fair enough. And it turns out, so the original transformer architecture, one of its purposes was translation. So the closer we can get to a fully specified translation from, hey, here's one language, bring it over from Python semantics into JavaScript or TypeScript semantics. Here's a full description, specification of all desired functionality, calling out all the edge cases and everything else, and providing you with all these test suites that provide feedback the moment that you start to go off track. The closer you get to this ideal, the better your results are going to be when dealing with agentic workflows, coding agents, etc. So I love the research that both Emil and Simon did. I think it's incredibly important when people share both their successes and failures. It would be very easy for Emil to have kind of ridden off the work that he did, and he almost did. He had kind of a moment of uncertainty. Is this actually doing anything? Here's his Jesus in the desert moment, asking why build this at all? He had an uncomfortable thought. Does the world really need a slower version of this Rust library that he started to port? He started off with trying to do this from scratch, and he found out he could not do it from scratch. However, he could do it from these other starting points, and that's still valuable, and that still got us 2 subsequent ports, which means that Python has a strong port, and now JavaScript does as well, that hits all these unit tests and passes everything, and that's really nice. All right, thanks. That's all I got for today. Have a good one. Goodbye.